As we learn about the unit circle, the first thing I want to talk about are the angle measures that get created in a unit circle. Now, a unit circle is basically just a circle with a radius that's 1 unit. It doesn't really matter, though, how big it gets, because as it grows proportionally. These angle measurements are going to stay the same. So, this is just the degree measurements, and as you were in geometry, you probably used a protractor and learned to there. But this is just a continuation. You keep on going all the way around and you get to 360 degrees. So if you're just here to begin with, that's 0 degrees. But as you go around the full circle, and if you go all the way around, now it's 360 degrees. All right. So hopefully you kind of know those angle measurements. The sooner you learn your degree measurements, the easier it all is. And really the quicker you force yourself to study all of this, the easier it will be. All right, so what I really want to talk about then is the radian measurements, because that's what's new to us in this course, is the radian measurements. So we've talked about already that if you go all the way over to here, that's pi radians. So I'm going to put, okay, so now ideally you have your degree measurements put into your unit circle, and you should be using your copy of your unit circle, not notes. Let's put this on your formal unit circle sheet. And if you need to draw one, then draw one. You could probably Google one. If you're ever needing to pause this video so that you can fill in on your unit circle, then go for it. Just pause it, fill in the numbers you need, and then start it up again. This is a pretty thorough explanation of your unit circles, so it does get a little bit lengthy, but I'm going all the way through every part of your unit circle. You're going to have a lot to write at each one of these dots on your unit circle, so please write little, and you might change colors, use a red pen, use a blue pen, use a pencil as we do each type. So here's the degree measurements, have that in one color. Now change colors. I'm going to go through now and we're going to do the radian measurements. And we've talked a little bit about radians, and if you've missed more than a day, then maybe you don't remember or hadn't learned, but when you go all the way around a circle, that angle measurement is 360 degrees. In radian measurement, it's 2 pi. So 2 pi radians. So in here, I'm going to write 2 pi. Now that's assuming I went all the way around. If I didn't go anywhere, it would still be 0. So just like it could be 0, 360, it could be 0 or 2 pi. So let's start breaking this circle up then. If it's 2 pi all the way around, how far is it just halfway around? Well, that'd have to be 1 pi, or just pi. And so then, if that's 1 pi, what would it be just to here? Well, that's halfway to pi, so it's half of pi, or we write that pi over 2. And if you go straight down, you'd be at 1 and a half, so we write that 3 pi over 2. Sorry, that was right on top of that. 3 pi over 2. Now, let's go back and let's look at our 45 degrees. Our 45 degree marks, if you look right here, every 45 degrees, I got 4 of them right there until I got to pi. So that means this is 1/4, this is another 1/4, another 1/4, and another 1/4 of pi. So I would write this right here as 1/4 of pi. We write it pi over 4. And then as you go around, this would be 2/4. That reduces to pi over 2, so we've already got that one. This one here is 3/4 of the way to pi. So 3 pi over 4. This one is 4/4. Let's keep going. Here's 5/4. The one straight down is going to be 6/4, but that reduces to 3/2. And then over here is 7/4, 7 pi over 4. And then back up here is 8/4, which is the same thing as 2 pi. So all of the 45 degree marks, you can tell they're 45s on the angles because they have 5s on them. They're the only ones that have 5s. Those are your 45 marks. Same thing with the radians. They're always 4ths on your 45s. Now let's look at your 30 degrees. So again, you got to think, well, 30 degrees is what part of the way to 180? Well, 180 divided by 30 is 6, so this is 1/6 of the way. And every 30 degrees will be 1/6 of the way over here to pi. So let's count it up, or let's write it down. This is 1/6 of the way, so we write it pi over 6. At 60, I'm at 2/6, but 2/6 will reduce, and we always want to reduce if we can. So this is going to be pi over 3, or 1/3. Okay, another 30 degrees takes me to 90, and so that's 3/6, which reduces to 1/2. So I've already got that. Here's 4/6. 4/6 would reduce to 2/3, so 2 pi over 3. And then I'm to 5/6, and 6/6, which is just 1, so that's my 1 pi. Here we go, 7/6. Next one is 8/6, but 8/6 would reduce to 4/3, so I'll write that 4 pi over 3. And then straight down is 9/6, which reduces. Here's 10/6. 10/6 will reduce to 5/3. Another 30 degrees is 11/6. And then one more is 12/6, which reduces to 2 pi. So we've got it. All right, so those are your radian measures. And I know that the degrees makes more sense in your head because you've used those more, but we really in Trig use the radians more. So try to practice that, do some flashcards, do something to help remember what those radian measurements are all the way around the unit circle. All right, that's 2 down. We have 3 more things to fit in on each one of these angle measurements. So you're going to be needing another color. We need a little background knowledge before we move on, and so I've got a little geometry review for you. Let's look at it. All right, before we jump in and look at the unit circle, we need to recall a little bit of stuff about geometry here. And you may or may not recall the special right triangles from geometry. There's a couple right triangles that have special angle measurements and thus have some special relationships that we need to know. One of them is called the 45-45-90 triangle, and you can look at that and see that it's really just an isosceles triangle. And so we call it an isosceles right triangle. It's going to have 2 legs that are the same length. If the base angles are both 45, then the 2 sides are going to be the same. Not only are the 2 sides the same, then through some Pythagorean theorem we get to the relationship that the hypotenuse of your right triangle is always going to be the square root of 2 times that leg measurement. So if this was a 7, then this would have to be a 7, and this would have to be a 7 square root of 2. Now that works out nice if you know the legs. Sometimes we try to work backwards, and so let's do a little bit trickier one here. Let's say we know the hypotenuse, and let's say it's something like 4. Well, to get to the leg measurements then, we'd have to get rid of this square root of 2. So if you think of this like 4 is equal to the square root of 2 times x, and I want to know what x is, I would divide by the square root of 2. So this divide by the square root of 2 thing is how you get back to the sides. So we would typically rationalize that. So multiply by root 2 over root 2. You get 4 root 2 over 2, which then simplifies to 2 root 2. All right, so that's just an example of what we kind of are doing, is we would have to divide by the root 2 to get back to the legs. That's on a 45-45-90. Let's look at a 30-60-90 triangle. On a 30-60-90 triangle, you have a hypotenuse, you have a short leg, and you have a long leg. So the short leg is the one that's the base for the other 2. We just call it x, whatever it is. The hypotenuse will always be twice that length. So if this was 4, then this would be 8. The long leg of the 30-60-90 is always going to be your short leg times the square root of 3. So in this example, it would be 4 square root of 3. Now if you aren't given the short leg, that's the easy route, is if they give you the short leg. If they maybe instead give you the hypotenuse, well, you can backtrack through it. You always kind of backtrack back to the short leg. So let's say this was 10. Well, the short leg is half as long as the hypotenuse there, so this would be 5, and then I could come up here and say this is 5 root 3. If instead they gave you, let's say, the long leg, and they said this was, we'll say 12. Well, to get back to the short leg, I got to get rid of this square root of 3. So basically what I'm saying here is the square root of 3 times x, or x square root of 3, whichever way, is going to equal 12. So I'm going to divide both sides by the square root of 3. And that's the step right there that you got to remember. You're going to have to divide by the square root of 3 to get back. So x is going to equal, and I'm going to go ahead and rationalize on this same step. So 12 root 3 over 3, which would simplify to 4 square root of 3 for the short leg. So you need to kind of remember those relationships. Now that was special right triangles in a quick nutshell. Let's move on. All right, so let's use those geometry features and relationships and transfer them to something that's more circular. What we do oftentimes is we create what we call the unit circle. It's a circle that has a radius equal to 1. And oftentimes we'll put it like on the XY axis and draw it like this. So the radius on this, that's an ugly circle, sorry. The radius on this is 1 unit. So regardless of where I draw the radius, I know that that distance is always going to be 1 unit. Now what I've done down here below is I've just pulled out this top corner of the circle. And that's all I'm looking at for right now. We'll bring in the rest of it in a little bit. So looking at this triangle that I've drawn in this first one here, I've created a 30-degree central angle. And I've drawn my radius, so I know that's 1 unit. And then what I do is I drop straight down to the x-axis, and I create a right triangle here. Now because I made this 30, and this is a 90, this becomes a 30, 60, 90 triangle. I want to look at some trig functions with these angle measurements. So, like for instance, on this 30-degree angle, let's look at the sine of that 30-degree angle. And in fact, I think I'll go through and I'll do the sine on all of these, and then we'll come back and we'll do cosine of all of those and look at some relationships. So on this example, if I wanted to find the sine of this 30-degree angle, remember that sine is opposite over hypotenuse. So I need to know this measurement here. So going back to the special right triangles, remember that the short leg is always half the hypotenuse. So in this case, this short leg is 1/2. And so the sine of a 30-degree angle would equal 1/2 over 1, which is really just 1/2. So the sine of a 30-degree angle is 1/2. Let's look at our 45. On a 45-degree angle, again, we're looking at opposite over hypotenuse, so I need to know the opposite. I'm going to have to take 1 and divide it by root 2. So let me come up here, 1 divided by root 2, rationalize it, and we get the square root of 2 over 2. So that means this value is root 2 over 2. And when I do the sine of a 45, and I take the opposite over the hypotenuse, I'm going to have the square root of 2 over 2 over 1, which really just equals the square root of 2 over 2. All right, last one. Let's try it with the 60. With a 60-degree angle, the sine is opposite over hypotenuse. The opposite is my long leg this time. And if you recall, this is really the same triangle, and this is important to notice that this is the same triangle as this one. It's just tall, whereas this one's long. So the side measurements are the same. This is still my short leg, so I know that's going to be 1/2. And so my long leg would be that times the square root of 3, which would end up being the square root of 3 over 2. So when I do the sine of a 60-degree angle, it's going to equal the opposite, which is root 3 over 2, over the hypotenuse, which is 1. And so the sine is the square root of 3 over 2. Ooh, that's a 2. That's ugly. Now, what did you notice consistently happened with all three of these? Well, every time when you put the opposite over the hypotenuse was always 1, every time. It wouldn't matter what kind of triangle I drew in there, my hypotenuse is always 1, because it's a unit circle. So really, I don't even need the hypotenuse on this. I could just use the opposite. And so that opposite leg, every time, was how far up it went. Notice that it's how far up that's going. So however far up it goes, whatever that long leg here, or the short leg here, or just the same leg on that one, whatever that vertical distance is, always ended up being my sine value here. Okay, that's worth noting. We'll come back. The sine value is that vertical distance that I go. We'll come back and jot it down. Okay, so let's try this again, but this time instead of looking at sine, we're going to look at the cosine of these angles. Now the triangles are the exact same, so I went ahead and filled in the numbers for us. So let's look at what the cosine would be. The cosine of a 30-degree angle is equal to the adjacent, which would be this, over the hypotenuse. Adjacent over hypotenuse. What do you notice again with your hypotenuse? It's just going to be 1. Let's just look at all of these. Adjacent over hypotenuse. Again, it's over 1. Adjacent over hypotenuse. Again, it's over 1. So the cosine is really going to end up just being the adjacent side. So for this one, it's root 3 over 2. The cosine of a 45 would have to be a root 2 over 2. The cosine of a 60 would have to equal 1/2. Now the way that this is similar to the sine is that you really only need one side of your triangle. For the cosine, it was the adjacent. For the sine, it was the opposite. Okay, so for the sine, or the cosine, since we're looking at that, this adjacent side happens to always be how far over you're going, your horizontal distance. So if you're going over a lot, that's a root 3 over 2. That's your long leg. If it's your short leg, then it's only going to be a 1/2. So what we're going to do is look at these triangles in here and decide, all right, the horizontal distance is always going to be my cosine value. The vertical distance is always going to be my sine value. So what I'm going to do here is look at these points. Here's from the 30-degree angle. Here's the 45. Here's the 60. You can kind of envision those triangles drawn, but it gets pretty cluttered, so I pulled the triangles out. But here would be your 60-degree angle, so it's a tall, skinny triangle. Here's your 30-degree angle, so it's a long triangle. And then here's your 45, where you're going up and you're going over the same amount. Always envision those triangles drawn out inside of there. What I'd like you to recognize is this point right here that's on the unit circle. This point actually represents the sine and the cosine of this 30-degree angle. Remember that, and I'm going to write it up here, this ordered pair for this point would be how far, this point here is how far over I'm going, which happens to be the cosine value, and how far up I'm going, which happens to be the sine value. So we're going to add in, right here, basically an ordered pair. Well, and let's write this up here at the top of your unit circle page. You're going to want to write that it's a cosine theta is your x value, comma, sine theta is your y value. If you write it as an ordered pair, this will help you remember that cosine is your horizontal movement, sine is your vertical movement. So let's go around, and I'm actually going to start with those 30, 60, 90s here. So okay, I maybe lied. Let's not start with the 30, 60, 90s. Let's start with something easier. I'm going to start with all these 45-degree angles. And what I'm going to do is try to figure out what this ordered pair right here would be. Because I know that ordered pair not only is an ordered pair that would be plotted, it tells me my cosine and my sine value right off the bat of that angle. So looking at this, looking back at your previous one on the 45, how far over did we go? And the answer was root 2 over 2. And remember that on the 45, the over and the up were the same. So the sine value is also root 2 over 2. Now I'm going to go around this whole circle, and I'm going to write the x and the y coordinate, which is your cosine and your sine of that angle. Let's come over here and let's look at this triangle. what if you go to this 45-degree angle right here? Now I know it's not really 45 until you put in that triangle. Now that's a 45. Okay, with that, we could find the over and the up amount. Remember, it's still a 45-90 triangle, so how far I go horizontally and how far I go vertically is still the same, and they're both going to be that root 2 over 2. What's different in this quadrant is when I move horizontally, I'm actually going left. So I'm going to end up having a cosine value of a negative value. So it's going to end up a negative root 2 over 2. But I'm still going up, so my sine value is a positive root 2 over 2. Let's keep going around the circle on these 45s. Here's the next 45. When you're drawing that circle, you always drop it back to the x-axis. So there you can kind of see your 45, 45, 90 triangle. So when I look at for this point here, how far over I go is going to be root 2 over 2, and I go down root 2 over 2. So that means, let me erase that off there, the cosine is still going left, so I'm going to go negative root 2 over 2. And I went down, so my sine value is also going to be negative root 2 over 2. All right, last one. What do you think this ordered pair is going to be for this 45? You're going right, so root 2 over 2. Cosine is positive, but you're going down, so your sine is going to be negative. All right, so you basically know the sine and the cosine of any of those 45 marks is always going to be a root 2 over 2. You just have to pay attention to whether it's positive or negative. All right, let's do really the easiest ones. Let's look at the quadrantal angles. There's not really even ordered pairs or not even triangles to be looking at. If you look at those 4 points, you know what that ordered pair is. It's a unit circle. The radius is 1, so I'm right 1, up 0. This one, I'm over 0, up 1. These would be easy ones to check on your calculator. Remember, the first letter or the first value is your cosine, so you could do like the cosine of a 90-degree angle, and I bet you get a 0 back on your calculator. All right, one last one down here, over 0, down 1. Okay, last ones are the 30s, 60, 90s. These are a little bit trickier. I'm going to change colors on this, but you probably don't need to because we've got a lot going on between all the different things we're going to put on these points on the unit circle. You can keep the same color. All right, so this is a 30, 60, 90. You got your 30-degree angle there. And so you've got a long leg and you've got a short leg. So remember that the short leg is 1/2 here, and the long leg is root 3 over 2. So you're constantly thinking about, is that my short leg or is that my long leg? So as I do this one, my horizontal distance, my x, my cosine, is root 3 over 2. My y, I'm up, my short leg is 1/2. If I were to go to this one over here, I'm going to change colors one more time. I know it's starting to get cluttered. This is probably the last time I draw on it here. Here's my 30, 60, 90. This time it's switched. It's a tall triangle. So my short leg is now on the bottom. So that's my x value. It's 1/2. And my long leg is my vertical distance, or my sine. So that's my root 3 over 2. So as we go around, we have to decide, first of all, for this one, if I were to draw this triangle in here, you always drop straight down to the x-axis. That's where your right angle is. All right, my horizontal, my cosine, is my short leg, so that would be 1/2. Except that I went left, so it's a negative 1/2. And my vertical distance is my long leg, my root 3 over 2. All right, next one in this quadrant is right here. So if you can envision going up there and then dropping back to the x-axis. So your horizontal distance is your long leg this time. So cosine is the root 3 over 2, still going left. And then I'm up my short leg, that's 1/2. Let's keep going. Now we're down in the next quadrant, down here. So my horizontal distance is my long leg, that's root 3 over 2. I'm still going left. But now I'm also going down, so my sine value is also going to be negative, and I'm down the short leg, 1/2. Next point, right here. I'm left my short leg, down my long leg. So left the smaller amount, down the longer amount. Okay, right here. Next point. This one, again, I'm drawing my triangle, I follow the angle, and then I drop straight to the x-axis. So here's my triangle. So it looks like I'm over, it's really just the reflection of this black triangle here. It just flips down. So here's my short leg, there's my long leg. So I'm going to the right, 1/2. I'm going down root 3 over 2. All right, last one right here. And I'm going right a lot, that's my long leg, and I'm going down the short leg. Now by finding those right triangles and writing all of those as ordered pairs, it's just a concise way to recognize and notate the sine and cosine of many common angles. So if you can envision where you are on the unit circle, you can quickly determine the exact value for your sine and cosine and not be using your calculator. Those are rounded values. So these are exact values. Not all angles will come out nicely, but these are the ones that do. All right, here's the last thing we're going to put in this unit circle. So you might change colors again and write little, I guess. Okay, so let's look at the tangent. We did sine and cosine for all these common angles. What about the tangent? All right, just like there's some commonalities and some patterns with the sine and cosine, there are with tangent as well. If you look at these different triangles that we have been talking about, remember that the tangent is always your opposite over your adjacent. So opposite over your adjacent. Your opposite over your adjacent. Oh, that's just always going to be the sine, the y, the vertical, over the cosine, or the horizontal, or the adjacent, whatever you want to think about. Okay, so really to find the tangent on each one of these, I could just take this vertical distance over this horizontal distance, or my sine over my cosine. The problem is that this is a much messier because you're not using your hypotenuse, your nice pretty 1 number. So let's do a little bit of quick number work here. I'm going to take my opposite and put it over my adjacent. Then I'm going to bring this up and multiply by the reciprocal. Oops, that's going to be a 2 then. Over the square root of 3. The 2's are going to cancel nicely, and I get 1 over the square root of 3. But then I want to rationalize that, so root 3, and so my final answer on that one is the square root of 3 over 3. That's the tangent on a 30-degree angle. Let's try it. I'm going to jump over to the 60 since it's going to have the same numbers, but this time when we do opposite over adjacent, you're going to have root 3 over 2 over 1/2. So root 3 over 2 over 1/2. Bring this up and multiply by the reciprocal, which is 2 over 1. The 2's cancel. This works a little nicer. It's just going to be a square root of 3. I don't have to rationalize. So the tangent of a 60-degree angle is always the square root of 3. Last one, let's try the tangent of a 45. You've got your opposite and your adjacent. So that's a root 2 over 2 over root 2 over 2. And you might be able to think through that in your head, or if you got to write it out, here's my 2 over my root 2. 2's cancel, root 2's cancel. Everything, remember what I'm supposed to do when I cancel things out is leave 1's in their place. It's just a 1. They're the same. If I put this over this and they're the same number, it's going to equal 1. So the tangent of a 45-degree angle is 1. So these are your 3 numbers. This is all there's going to be. you're just wrapping around this unit circle and you keep coming across these exact same three triangles. The only difference is they're in different quadrants, so you have to start paying attention to where they fall as far as their signs, whether they're going to be positive or negative. So let's go to our unit circle and let's start filling in, and we'll start with the easy ones. We're going to probably start with the quadrantal angles, then we'll do our 45s, and then we'll come back to our 30, 60, 90s. So again, maybe a new color. Let's add this in on our unit circle. Okay, and let me say one more thing so I don't have to come back to this slide. What you need to recognize between these 30, 60, 90 triangles, these two, is that this one is kind of laying flat. It's your long one. So it's anytime you have the long looking triangle, that's going to be root 3 over 3 for your tangent value. But if your triangle is tall, like this one is more tall, then your tangent value is going to be the square root of 3. The square root of 3 is bigger than the square root of 3 over 3, because this is basically just divided by 3, so definitely going to be smaller than your root 3, which kind of makes sense because you're higher here. Your y value that you're taking and dividing by your x value, this is a bigger number. So then the tangent should be bigger on your tall triangles. All right, so let's go look at one and go back to your unit circle and let's fill it in. Okay, let's start with the easy ones. All right, I'm going to start with the quadrantal angles, which are the ones on all of your axes here. Now all of these, if you look at your sine and your cosine, have zeros and ones. And so remember, if you're going to ever take 0 and divide it by 1, well, that's 0. But if you take 1 and divide it by 0, that's undefined. So remember that it's your sine over the cosine as you do your tangent. This is your y value, your vertical or your opposite, over your cosine or your x value. So you're looking for any time that your sine value, where you're up 0 and over 1, up 0 and over 1 would be here, and this one would be over -1. Those two are going to be the ones that look like this. So those tangent values are going to be 0. The other ones, your sine value is 1 because you're up a lot, or maybe -1, down a lot, but you're not over anywhere. Your x value is 0. That's going to be undefined. So that's going to happen here and here, where you're up or down 1 over 0. So those are going to be undefined values for your tangent. All right, let's move on to the 45-degree angles. These are the easy ones because remember, on this 45, how far over is the same as how far up. The sine and the cosine are the same, or really I should say the sine and the cosine are the same, so the tangent value ends up equaling 1 on all the 45s. The only thing that you have to pay attention to is whether it should be positive or negative. So in this next 45, since I'm going left, that's negative, up is positive, so that's going to end up being a -1. On this one, since I'm left and down, those are both negative, that's going to turn to a +1. Over here, I'm right and down, that's positive and a negative, so that's going to end up being a -1. All right, so let's look at your 30, 60, 90 triangles. Remember, all of the triangles that were long and skinny, the ones like this one that were long and skinny, had a root 3 over 3. So that's going to be like this one, or this one over here is long and skinny, or the ones right below it, and this one. These are your long, skinny triangles. So all of those are going to be root 3 over 3s for your tangent. Oops, 3. However, some of these are going to be positive and some of these are going to be negative. So again, you're looking at your sine and cosine on if they're both positive or one's negative or what you got going. So, and this is consistent. In this quadrant, let's just decide this right here. In this quadrant, your sine and cosine are both positive, so your answer, your tangent is going to be positive. On this one, your left, which is going to make that negative, but you're up, so that's positive. So these are all going to end up negative values. Down in this bottom quadrant, since your left and down, your sine and cosine are both negative. You can see that because it's written. And so those are going to be positive. Look at that. Did you catch that I wrote a root 3 over 2? I'm just used to writing root 3 over 2. These are root 3 over 3's for your tangent. Don't make the same mistake I did. All right, so one more time. This quadrant, everything's going to be positive. But over here, since only the sine is negative, all of these are going to be negatives. So let's put a negative on that. All right, let's do the last one. Let's do those tall, skinny triangles. The tall ones that come up and down like this, or this one over here, or this one here, or this one here. Those are all your root 3's. So paying attention to your sign, this is going to be a positive root 3. This will be a negative root 3. Down here's a positive root 3. Here's a negative root 3. So a couple things to help you remember your tangents. If you look at this, it's these low ones right here, these ones that are close to the x-axis. These are all your root 3 over 3's. That's how we built it. Those are your root 3 over 3's, the ones close to the x-axis. The ones that are close to your y-axis, the tall ones, these are all of your root 3's. You might also notice your radian value. These root 3's are all your pi over 3's. And then the other thing that kind of helps me remember which ones are 0 and which ones are undefined, you can kind of think of it like slope. Not that it has to do with slope, but remember slope of horizontal lines is 0. Slope of vertical lines is undefined. So that might help you remember. And then your 45's are always those ones. So I know it's a lot to try to remember. The more you look at it and practice with flashcards, those triangles are going to make sense in your head, and you'll get the hang of it. I promise you will. You just have to practice. All right, that's all I've got for you. Good luck. Go study.